Hey, it is Adam here. Today we are finishing off the room search skills. But before we jump into the technical parts of this room, let's take a quick look at what this lesson is actually about. By the way, you don't need to read the room text. I'll explain everything and cover everything it includes. What I consider important is that you can apply the knowledge you gain here in the labs. So let us start. When you search for information online, you're entering an environment where literally anyone can publish content. That could be blog posts, articles, forum comments, or even edits to public wiki pages. Because of that, the internet contains an enormous amount of information, but not all of it is reliable, especially nowadays, sadly. So, one of the most important skills in cybersecurity isn't just finding information, it's knowing how to evaluate the information you find. In other words, when you read something online, you shouldn't automatically assume it's correct. Instead, you need to think about questions like, who created this information? Is the source trustworthy? Is there evidence supporting the claims being made? And do other reputable sources agree with it? This is especially important in cybersecurity where incorrect or misleading information can lead to serious mistakes. Now, in this room, the goal is to build practical search skills that help you navigate the massive amount of information available on the internet. By the end of this lesson, you should be able to evaluate whether a source of information is trustworthy. Use search engines more effectively. Discover specialized search tools used in cybersecurity. Locate and read technical documentation. And make use of other information sources like social media and news platforms. So now the room starts talking about something really important, evaluating information you find online. Because the internet is open to everyone. Anyone can publish content. That means blog posts, social media threads, wiki edits, and articles can all appear authoritative, even when they're not. So the responsibility falls on you as the reader to determine whether the information is actually reliable. There are a few key things you should look at when evaluating any source. First, the source itself. You want to identify who created the content. Is it an individual blog post, a well known organization, a research group? Just because someone publishes an article doesn't automatically make them an authority on the topic. Credibility matters. Next, look at the evidence and reasoning. Like, reliable information should be supported by facts, research, or logical explanations. If a claim is made without any supporting evidence, that's usually a warning sign. Then there's objectivity and bias. Sometimes content is written to promote a product, push an agenda, or criticize a competitor. When evaluating information, you should consider whether the author is presenting facts objectively or trying to influence the reader. Another important factor is corroboration and consistency. A single source saying something isn't always enough. Ideally, you should be able to verify the same claim across multiple reputable sources. If independent sources agree on the same core idea, that information becomes much more trustworthy. So, overall, evaluating online information comes down to asking a few key questions. Who published this? Is there solid evidence? Is the information unbiased? And do other sources confirm it? Now, after introducing these evaluation principles, the task gives us a couple of questions that require us to search for specific information. The first question asks, what do you call a cryptographic method or product considered bogus or fraudulent? And for this, you can just use a search engine and it will tell us a cryptographic method or product considered bogus, fraudulent, or deceptively marketed as secure is called snake oil. Now, the second question asks, what is the name of the command replacing netstat in Linux systems? So let's search it in a different way now, like new netstat command in Linux. And the result is double S. All right, so in this task, the room starts focusing on something we all use constantly, internet search engines. Most people already use search engines every day, but the key idea here is that many users only use them in a very basic way. They type a few words into the search bar and click the first result they see. Today, many people ask AI instead of using search engines. Even Google now shows AI summaries at the top of results. But in cybersecurity, professionals still verify the original sources before trusting the answer. However, search engines actually provide much more powerful ways to find information, especially when you start using advanced search techniques. First, the room briefly mentions a few common search engines. Some widely used ones include Google, Bing, DuckDuckGo. Never seen anyone using Bing though, only by mistake. Each of these platforms allows you to search the web for information, but they also support special search operators that help refine your results. These operators allow you to control how the search engine looks for information, which can dramatically improve the accuracy of your results. Now let's look at some of the most useful ones. The first one is the exact phrase search. This uses quotation marks to tell the search engine that you want pages containing that exact phrase rather than pages containing those words scattered anywhere. This is useful when you're looking for very specific terminology, so let's test it with something. Here you can see the difference. On the first search, without quotes, Google shows results that contain the words password, security, and tips anywhere on the page. But when we add quotation marks, password security tips, Google now searches for that exact phrase. This usually gives you more precise results. Next is the site restriction operator. This operator lets you limit your search results to a specific domain. In other words, you can tell the search engine to only return results from a particular website. This is extremely useful when you're trying to search within a trusted source. Let's check an example for this one too. As you can see, Google will only show results from the NIST website. This is useful when you want information from a trusted source. Then there's the exclusion operator. This allows you to remove results containing a particular word. It helps filter out irrelevant content that might otherwise clutter the search results. And finally, there's the file type operator. Instead of searching for normal web pages, this operator lets you search for specific types of files, such as PDFs, Word documents, spreadsheets, or presentations. This is particularly useful in cybersecurity research because many reports, research papers, and technical presentations are published in document formats rather than standard web pages. Now, after explaining these operators, the task asks a practical question. The question is, how would you limit your Google search to PDF files containing the terms cyber warfare report? Well, it just happens that we used it, so let's copy it there. Hmm, what a coincidence, right? The next question is, what phrase does the Linux command SS stand for? Let's just copy this question as it is to check it. And we can move on to task legendary number 4, specialized search engines. All right, so up to this point, we've been talking about general search engines like Google. They're great for finding information across the web, but in cybersecurity, we often need tools that search very specific types of data. And that's where specialized search engines come in. These platforms focus on particular kinds of information, things like internet connected devices, websites, certificates, files, or leaked credentials. Because of that, they can be extremely valuable for security research, reconnaissance, and investigations. The first tool mentioned in this task is Shodan. Shodan is often described as a search engine for internet-connected devices. Instead of indexing normal web pages, it scans and indexes devices that are exposed to the internet. This includes things like web servers, routers, industrial control systems, IoT devices, cameras, and other embedded systems. In other words, Shodan is basically Google for things that probably shouldn't be on the internet in the first place. Shodan collects information from these systems and allows users to search for them based on things like software versions, open ports, and service banners. For example, if you search for a specific server version, Shodan can show you how many systems on the internet are running that version and where they are located geographically. Pretty good stuff, by the way. Next, the task introduces Census. At first glance, Census may seem similar to Shodan, but its focus is slightly different. While Shodan mainly indexes devices and services, Census focuses more on internet hosts, websites, certificates, and other internet infrastructure. Some common use cases include identifying domains in use, auditing exposed services and open ports, discovering unknown or rogue assets within a network. Because of this, Census is often used for large-scale internet measurement and security analysis. The next tool discussed is VirusTotal. VirusTotal is an online service used to analyze files or URLs for potential malware. Users can upload a file, submit a link, or even provide a file hash. The platform then scans that file using many different antivirus engines simultaneously. Think of it as getting 50-second opinions at once. This allows security analysts to quickly determine whether a file has already been flagged as malicious by any security vendors. VirusTotal also includes community comments, which sometimes provide additional context about suspicious files. Another service mentioned is Have I Been Pwned? This platform checks whether an email address appears in known data breaches. If an email address is found in leaked breach datasets, it usually means that some associated information, often including passwords, has been exposed. Fun fact, the owner of this site was pwned not a long time ago. How the tables, how the chair, turns. This is particularly dangerous because many people reuse the same password across multiple platforms. If one service is compromised, attackers might gain access to other accounts as well. All right, after introducing these specialized search engines, the task gives us two questions. What is the top country with light TPD servers, or whatever? I have no idea how to pronounce it right. For this, we are going to use Shodan. And it is United States. Now, the second question asks, what does Bitdefender Falx detect the file with the provided hash as? To answer this, you would take the given hash value and search for it on VirusTotal. Task number 5, vulnerabilities and exploits. All right, in this task, the room introduces one of the most important concepts in cybersecurity, tracking vulnerabilities, which is basically the cybersecurity version of keeping a list of all the ways software can accidentally betray us. When security issues are discovered in software or hardware, they need a standardized way to be referenced. Without a common naming system, different researchers and organizations might refer to the same vulnerability in different ways, which would quickly become confusing. And cybersecurity already has enough confusing acronyms. So to solve this problem, the industry uses something called the CVE system. CVE stands for Common Vulnerabilities and Exposures. You can think of it as a dictionary or catalog of publicly known vulnerabilities. Each vulnerability is assigned a unique identifier called a CVE ID. So instead of saying that bug from 2 years ago that breaks everything, we can say something like CVE-2021- and other numbers associated to it, like 1, 2, 3, 4. These identifiers follow a standard format that includes the year and a unique number. The important thing about CVE IDs is that they allow security researchers, vendors, and organizations to refer to the exact same vulnerability without ambiguity, which is very useful when everyone on the internet is panicking about the same bug. So, the CVE program itself is maintained by MITRE, which manages the database and coordinates vulnerability identifiers. Um, in other words, MITRE is the organization that keeps track of the internet's growing collection of, well, that was a bad idea. If you want to search for vulnerabilities, there are two major resources commonly used. The first is the CVE program website, where you can search for vulnerability identifiers and descriptions. Think of it as the official catalog of known security mistakes. Another important resource is the National Vulnerability Database, often called the NVD. This database expands on CVE entries by adding additional details such as severity scores, impact metrics, and remediation information. So not only do you see the problem, you also see how bad the problem actually is. Now, knowing that a vulnerability exists is only part of the process. In many cases, security professionals also want to find exploit code that demonstrates how the vulnerability can be used, because reading about the problem is useful, but seeing how it works is usually much more educational. This is where exploit repositories come into play. One well-known resource is the exploit database. This database contains publicly available exploit code written by security researchers. Some of these exploits are tested and verified, which means they have been confirmed to work against the vulnerable software, which is both extremely useful and slightly terrifying. Another place where exploit code frequently appears is GitHub. Developers and researchers often publish proof of concept exploit code or related security tools in public repositories. Searching GitHub for a vulnerability identifier can sometimes reveal scripts or tools related to that vulnerability. Because if something interesting exists on the internet, there is a good chance someone already made a GitHub repo about it. Of course, it's important to remember that exploiting systems without permission is illegal. These resources should only be used in authorized environments, such as penetration testing engagements or controlled labs. In other words, labs, test environments, or systems where you actually have permission, not random servers you found online. All right, after introducing these vulnerability resources, the task asks the following question. What utility does CVE-2 024-3094 refer to? Let's just open the site, which we can find in the room, and look it up in the search bar. It is XZ. Task 6, Technical Documentation. All right, so this task focuses on another critical skill in cybersecurity, reading official technical documentation. Yes, the thing most people try to avoid until something breaks. Instead of relying only on blog posts or tutorials, security professionals often go directly to the official documentation of tools and systems. These sources are usually the most reliable and up to date, and usually also the longest. One important example on Linux systems is the manual pages, often called man pages, which every Linux user eventually discovers at about 2 a.m. while trying to fix something. These are built-in documentation pages that explain how commands work. Almost every command on a Linux or Unix-like system has its own manual page. Some of them are only a few lines long. Others feel like reading a small novel. To view the documentation for a command, you use the man command followed by the tool name. For example, checking the documentation for the IP command can be done with man IP. This opens the manual page where you can read about the command's usage, parameters, and functionality. When you're done, you can exit the page by pressing Q, because at some point you will realize you opened it just to check one flag. This is actually a pretty important command, so pay attention. I use it daily as well. In many cases, you don't even need the man flag for a command. If you simply type the command and it requires additional input to function, it will often just display the manual page automatically, since it recognizes that you didn't provide the necessary input because you're an ignorant beta. If you prefer, many man pages can also be found online by simply searching for them. usually right after someone on Stack Overflow pastes the exact line you needed. But nowadays, people are lazy and just ask AI. The room also mentions that the AttackBox environment can be used to test commands like this directly in a Linux terminal, which is a much safer place to experiment than your production server. Besides Linux documentation, vendors also publish official documentation for their products. For example, Microsoft provides technical documentation for Windows commands and system features. Similarly, many software projects publish their own documentation, and sometimes those docs are the only place where a feature is actually explained. Examples include documentation for tools like Apache, PHP, Node.js, or Snort. If you are not familiar with these, don't worry, we will learn about them in our future videos. Checking official documentation is often the best way to understand how a tool actually works, even though most of us still try Google first or just throw it in AI. Now let's answer the questions for this task. The first question asks, what does the Linux command cat stand for? Well, we have sharpened our epic Google skills not so long ago, so copy paste it to Google. And it is concatenate, which is slightly disappointing if you were hoping it had something to do with actual cats. The second question asks, what is the netstat parameter in Windows that shows the executable associated with each connection? Once again, let us Google this epic question and let's see what we get. The correct parameter is B, which is also the flag that usually requires administrator privileges. But more on that in our future Linux fundamentals videos. Task 7, social media. All right, this task looks at social media as an information source in cybersecurity, which is basically the internet's largest collection of oversharing. Platforms like Facebook, Twitter, and LinkedIn contain a huge amount of publicly available information. For security professionals, this can be useful both for research and for security assessments, sometimes more useful than people realize. One key idea here is that people often overshare information online. This can include personal details, job roles, technologies they use, or even answers to common security questions, like posting your job, your tools, and your pet's name all in one place. From a defensive perspective, this is a risk. From an assessment perspective, it can be valuable information. Same data, different point of view. Social media is also useful for staying updated on industry trends, tools, and news, especially by following relevant communities and professionals. If you follow the right people, you'll hear about issues before they hit the headlines. Now for the questions. The first question asks, which platform would you use to learn about an employee's technical background? The most relevant platform for this is, of course, I guess LinkedIn. Basically a public resume people keep updating for you. The second question asks, which platform could help answer personal security questions like school history? A common source for that type of personal information should be Facebook, which often contains more personal history than people remember posting. All right, that completes task 7. Next is the final task where the room wraps everything up. Task 8. All right, so this final task is just a wrap up of the room, the part where everything suddenly makes sense, hopefully. The main takeaway here is that cybersecurity professionals rely on multiple sources of information, not just standard search engines, because one source is never enough when things go wrong. Throughout the room, we've seen how to evaluate information properly, how to use search engines more effectively, how to leverage specialized tools like Shodan or VirusTotal, how to read official technical documentation, and how social media and news sources can provide useful insights. Basically, how to find the right information instead of just more information. The key idea is that the information landscape is constantly changing. So, being able to find and evaluate information is an essential long-term skill because the tools will change, but this skill won't. There's no new technical step here. Just make sure you've understood the tools and resources covered in this room and maybe bookmarked a few of them. Once that's done, you can complete the task and move on, and that's it. Room finished. Like my will to live, GG. See you in the next one where we will start our Linux fundamentals journey, which is really important if you want to get your place in cyber security. So make sure you don't miss that one.